All right, so as I was saying, with these radio telescopes, we put them as far apart as possible, or well, sometimes we put them. Different experiments require different distances, but we can actually combine the images of multiple radio telescopes around the world, and effectively, at times, we can actually use the entire surface of half of the Earth at a time as a consider that the diameter of a radio telescope. All right, so that's there's this process called interferometry, where we combine different signals from different telescopes, and that gives us lots and lots of information. Of course, we analyze the information with our computers. All right. So there comes a point where, really, just with the atmosphere, will not allow, of course, most ultraviolet to pass through, or certainly any X-ray. It doesn't allow X-rays to pass through or gamma rays to pass through. So if we want to study those things, we have to, and to some extent, our atmosphere will block some of the infrared radiation, depending on what greenhouse gases are around, water vapor and carbon dioxide, of course. Anyhow, what do we do about that to avoid difficulties with the atmosphere? We launch spacecraft. We've been able to do this for the last 50 years, and hopefully a lot, going well into the future, launching spacecraft and to get above the atmosphere and get a better look out into the universe to figure out what's going on with the universe. All right, so they're just showing you some pictures from different space telescopes. Let's see. So this one was taken by the Herschel spacecraft, which actually operates in the infrared region. So which we usually associate that with heat, and then below that is what is that? Let's see. This is. They're just comparing the nebula using infrared and using optical, visible. The Spitzer Spitzer Space Telescope, it is also an infrared telescope, and that we use that to look out and actually Spitzer was used a few years ago to actually look into some of these nebula and some of the ones within our galaxy and even in other galaxies, and actually has shown us stellar nurseries and stars being formed inside of these stellar nurseries. All right. Here's a totally different telescope called ALMA. It's in, as I mentioned before, it's in the Atacama desert in Chile, and so it's operating it's kind of in the edge of the infrared, more towards the telescope. The radio region. And what's nice about this is it's in this desert, the Atacama Desert, where it hardly ever rains at all. There's actually parts of that desert where it hasn't rained for an estimated 10,000 years. So parts of the desert, not the entire desert, but so you get some really, really good observations of the early universe, of galaxies, of all sorts of observations. So these are all, again, tools that we use. Ultraviolet is, of course, you generally require space telescopes to to observe in the ultraviolet, because again, most of that is blocked by our atmosphere, and we kind of want the atmosphere to stay. Of course, we need it. All right, so now the problem with when you get up to X-rays, and especially when you get into the gamma regions, I mean, we do have telescopes in the X-ray. Probably the most famous one is called Chandra, the Chandra X-ray Observatory, which is of course a space telescope. There are actually some gamma ray telescopes as well, but it's actually really hard, it turns out, to bring the light to a focus with these extremely small wavelengths. So remember, gamma is the smallest of them all, and then comes X-rays, and then of course ultraviolet. So the shorter the wavelength is, the harder it is to bring it to a focal point. All right, this is a nice picture of let's see, is that that's probably what's called M1, the supernova that went off like 1,000 years ago in the constellation Taurus. It doesn't. Anyhow, that's taken with a X-ray telescope. So again, gamma rays are observed, but it's more of a general direction of where they came from. There's actually gamma ray telescopes that look for what are called gamma ray bursts. These are like the most energetic events. Some of the most energetic events that we observe. It can happen, like if, for example, if two neutron stars collide with each other, they create what's called a gamma ray burst. There are other reasons why gamma ray bursts are that can happen. Anyhow, one of the things that astronomers try to do, or some astronomers just concentrate on their own little region of the electromagnetic spectrum, but then different astronomers will look at some region, let's say, the Milky Way or some part of the Milky Way, and they'll try to look at it in the radio region, in the visible region, and the radio region, the microwave region, the visible region, and and then in X-rays, and then in gamma if they can. All right, so that finishes it up, and all right. So like I said, I'm going to try to have a video link. So this is just a YouTube. This will be just a YouTube video about the ALMA observatory. All right, I'll talk to you soon.